All right, Algebra 2, we are looking at synthetic division. So what we want to try and do is figure out either the factors of the polynomial or the zeros of the polynomial. And one way to do that is by factoring, which is what we're going to do here. It says, what are the zeros of this polynomial? And to solve this, we're going to go ahead and factor it. And to do that, we go, okay, what two factors of positive 6 give us the middle, negative 5? Since it's positive, they need to add to get 5. So it's going to be 2 and 3, where both of them are negative. And so that would be x minus 2 and x minus 3. Now, keep in mind, that is the factors, not the zeros. So to get the zeros, you set it equal to 0. For both of those, then you get x equals positive 2 and x equals positive 3. So that would be your 0. So sometimes we have polynomials that are bigger than just x equals 2. So we use what's called synthetic division to kind of figure that out. We do synthetic division because long division is kind of difficult and not that fun. So this is going to be a little weird at first, but once you kind of get the hang of it, it becomes a lot easier to kind of figure out. Okay, so if you look here, we have we've got 5 steps basically to go through and use synthetic division. So the first thing is to write the coefficients of the dividend in order of descending exponents, including 0. That's really important, including 0 for any missing terms. So it has to go in order, like x squared, x, then the constant. And then you're going to bring down the first leading coefficient, okay? Multiply by the divisor, which we'll talk about in a second, and then add down. And then repeat that step until you've got all of them bringing down. We're looking for that last number. So the first thing we do is set up our coefficients. So if it's a 1, I've got a box number, 1, 3, and negative 40. That is these numbers right here, 1, 3, and negative 40, okay? And in the box is going to go the 0 that we're dividing by, but this is the factor. So keep in mind, we do not want the factor, okay? We want to find the 0, so if you set it equal to 0, x equals 5 is the 0, okay? The 0 that you find goes in the box, okay? And so right here, this is 5. Not negative 5, but the 0, which is 5. And now we bring down the first term, and then we go. So bring down the leading term, that's step 2, once we have it all set up, and then multiply by the box. So 1 times 5, 1 times 5 is 5. So that's going to go right here. And then add down. Okay, so we did step 3, multiply by the box number, and then add down, that's 8. So repeat that. So I'm going to go 8 times 5, which is 40. And then add down, you get 0. So this last term is kind of separate. That's your remainder. And if you have a 0 of a remainder, that means that it checks out. Okay, so what we say is, since the remainder equals 0, which is kind of what we want, then that factor, x minus 5, is a factor, or is going to be be able to divide this polynomial, is a factor of the polynomial. Okay. And so what it also means is when you go back and look at your answer, this is the remainder, but these are your terms And if this is the constant, then it goes up from there. So this is really 1x. And so this is also a factor. Okay. And so if you were looking for like the zeros, let's say, we already have one 0, which was right here. And then the other 0 would be whatever this is when you set it equal to 0, which is going to be -8. Okay. And so we kind of do that same process for any of these situations. Okay. So for this second one, I've got all these numbers. So let's put them in order. I'm going to put a box, and I've got 2, -5, 5, -2. And then this number right here is a factor. So since this is the factor, I'm going to find the 0 by setting it equal to 0, and you get x equals 1. So that's what goes in the box here. Okay. So once again, I'm bringing down that leading coefficient, 2, and then I'm off to the races. So 2 times 1, 2 times 1, we get 2. Add down, that's -3. So once again, -3 times 1 is -3. Add down, that's 2. 2 times 1 is 2. Add down, that's 0. So again, that's separate from the others. That's our remainder. So that tells us x minus 1 is a factor. Okay. And so if I want to know what the remaining polynomial is, I bring all these down and put variables with them. So that's the, that makes this the constant. This is x. And then this is 2x to the second power. So it just kind of goes up from there. Constant, x, x squared, x to the third, and so on for how many you end up having. Okay? That's it. So if you get a 0 remainder, which is what we're trying to get, you do indeed have a factor. So let's go to the back side here. Try this next one. So first of all, you notice right here, x squared is missing. So when we put our numbers here, we have to include 0 in that spot. Okay? So 0 would be right here. So 6, -8. Oh, sorry, let's back up. 0's here. I've got my box here, and then 6, -8, 0, then 12 minus 14. And so right here I have the number in here is x minus 2, so the 0 is x equals +2. Okay, I kind of skipped a step, but all you're doing is setting that equal to 0, solve, and you get +2. So that's my box number. And so I bring down my leading coefficient, and now we're going. So 6 multiplied by the box, 6 times 2 is 12. Add down, that's 4. 4 times 2 is 8. Add down, that's 8. 8 times 2 is 16. Add down, that's 28. 28 times 2 is 56. Add down, that's 42. So again, that last one is separate from the rest, and that's our remainder, which means x minus 2 is not a factor. That's what that tells us. If it's not a 0 for the last spot, then we do not have a factor. Okay? And so if I am to write out the polynomial, again, I've got 28, 8x, 4x squared, 6x to the third. The other way you can think of that is like going, if we start with x to the third, then this is going to be x to the fourth, then this is going to be x to the third. It's just one less than what it was before. Okay? But now to write the remainder, if it's something other than 0, you write 42 over your factor. And your factor in this case was x minus 2. And I know that looks kind of weird, but that's how you would write your remainder, is over the factor that you divided by originally. Okay? And so, let's try the next one. So, we've got no missing terms. It goes 3, 2, 1, 0. So, nothing's missing. So, I've got the box, 1, -3, -4, 12. And the 0 that I'm going to be using is x equals -2. So the 0 is here, not the factor. So -2 is going in the box. And now I'm ready to go. So I bring down 1. 1 times -2 is -2. Add down, that's -5. Negative times negative is +10. Add down, that's 6. 6 times -2 is -12. Add down, that is 0. So that is what we want. And so that tells us that x plus 2 is a factor. And it also tells us what's left, what we call the depressed polynomial. It just means what's left. So all of this becomes, so since this is x to the third, this is x squared minus 5x plus 6 is the depressed polynomial, or basically what's left of the polynomial. Okay? All right. And so the very last one, we have a fraction involved here. So this one works out the same way. Okay, nothing weird about this, but again, we're missing a 3. So we need 3, or x to the third, I mean. So we need a 0 in that spot. So in the box, we've got something. We'll figure that out in a second. So 4, 0, -17, 14, -3. And in here, I'm actually going to use +3/2 or 1.5. Some of you might benefit from the decimal a little more, but either way, I'm going to use 1.5 just to make it decimal instead of a fraction. So 4 times 1.5, do that on my calculator, I get 6. Add down, that's 6. 6 times 1.5 is 9. Add down, that's -8. -8 times 1.5, that's -12. Add down, that's 2. 2 times 1.5 is 3. Add down, you get 0, which is what we want. That's our last spot. So that means b minus 3/2 is a factor. Okay? And so what's left? What's left of this polynomial? Let's just bring all these down. Okay, so since we started with b to the fourth, this one starts at b to the third. So 4b to the third plus 6b squared minus 8b plus 2. That is what the polynomial is that is left over. And so that is synthetic division. So we'll use that more this chapter to kind of figure out what other things do we know about this graph. Okay, so go ahead and try the homework problems, and then good luck in your SATs tomorrow, and I'll see you on Thursday. Peace.